All right, assalamu alaikum everyone. Now let's begin. In our last session, we started binomial expansion. That this is our second paper one topic that we're doing. So we started this topic. What's binomial expansion about? We can use this formula a plus b whole raised to power n equals this whole thing to expand these binomial expressions a plus b whole raised to power n. When can we apply this formula? When we have two terms, a and b, if they're being added together or subtracted together, we can just use this formula to expand this thing. The condition for the power is that it should be a positive integer. So whenever you've got two terms being added or subtracted and there's whole power, which is a positive integer, so this power n should be a positive integer. That's a condition. When that condition is met, we can use this formula to expand that thing. Right now, this formula has this notation, NCR. We have this button on our calculator. We can evaluate this. For example, 7C3. If we had to evaluate 7C3, we would just input 7 in our calculator, then NCR button, press the NCR button, and then 3, and that gives us 35. To evaluate these expressions, we just use our calculator, then input values and simplify everything and we get the result, right? So that's what we did in the last session. We learned how to apply this formula. And we also did a couple of questions after that. We looked at looked at a couple of questions after that. We saw how we could expand the first few terms of expressions like these. And then also what happens if there is one expression on which you have a power, and then there's another expression with which it's being multiplied, and you're asked about a specific term. For example, if you're looking for x squared term, you think about what you would multiply the first term by to get x squared. So if you wanted x squared as the result, the constant term would have to be multiplied with x squared. And what do you multiply kx by to get x squared? You multiply this by x to get x squared. And then you only need to do these multiplications and you can skip the rest of it. All right, so we talked about this in detail in our last session. Now, today what we're going to do is we are going to discuss how to find specific terms in a binomial expansion. All right, so a lot of times you'll see in problems where they will ask you to find a specific term. So for example, if you look at this question number 5 here, it says find the coefficient of x squared in the expansion of x plus 2 over x whole raised to power 6. Now, how do you find specific coefficients like this? That is what we are going to look at today. And then we'll also look at a few other examples where you have more than two terms. For example, if you look at question number 6 here, in this question, you see in the second part, you've got 3 terms, right? So you have 2 plus x squared. How do you deal with problems like these? You have to use some substitution to make it a binomial first, to make it 2 terms first, and then you can expand it and put that substitution back. We'll also talk about this if we have time at the end today. Otherwise, we'll spend another class in this on doing some more practice questions. And we'll discuss that in the next class then. But today, the focus is going to be how to find specific terms in a binomial expansion. All right, so that is what we are going to focus on in this particular class. All right, now we'll do that with the help of an example. Let me just open this and see which questions we should start from. All right, let's use one of these problems to learn how to find coefficient of a specific term or a specific term, whatever is required. Let's start with question number 2. And we'll use this question to learn how to find specific terms in an expansion. Now, there's a slight misprint here. I'll just write it down again. This is question number 2, and we'll learn this. We will use this to learn how to find specific term in an expansion. All right, let me just correct this question first. So this is actually something like this. It's 3x minus 2 over x. Let me just write all of that again. It's 3x minus 2 over x, and the power on top is 5. We want to find the coefficient of x in the expansion of this expression. All right. Now, how do we think about this? Let me just copy the formula here first. Remember, this is the formula that we've been using. A plus b whole raised to power n, this equals this whole thing. Let me just copy that formula here. We need to have that in front. Now, there are 2 methods for finding the specific term. Let's start with the first one, which I would recommend that you use. It's going to be quicker in most cases. There's another method as well. We'll discuss that as well. But I would recommend that you use this because it's going to be much quicker in most situations, in most scenarios. So how do we think about this? The first method works like this. All you've got to do is just expand it like you would normally do. So what's the expression? It's 3x minus 2 over x whole raised to power 5. All right. This is the expansion that you need to do. What do you have in place of a here? You've got 3x. In place of b, you've got minus 2 over x. And then the power is 5. All right. This is what we've got. Now, what do? We just input 3x in place of a. That's 3x whole raised to power n. The value of a is n is 5 plus nc1, that's 5c1 into a raised to power n minus 1, that's 3x whole raised to power 5 minus 1, which is just 4, into b, which is minus 2 over x, and so on. What you're going to do is you're going to stop at this point and think about what the powers look like for the first 2 terms. Why? Because you will realize that there will always be a pattern that is there in the powers of a binomial expansion. So if we look at the first term here, what's the first term? The first term is x raised to the power 5. What about the second term? You've got x power 4 in the numerator, and you've got x in the denominator. So that's x raised to the power 4 minus 1. That's x cubed. The second term has power 3, has x power 3. Now, what were you looking for? You were actually looking for the coefficient of x. That's x power 1, right? Now, what happens is, whenever you've got a binomial expansion, the powers are always going to have a linear sequence. And as we'll find later, when we do sequences, it's also called an arithmetic sequence. So the difference between powers is going to remain constant. So if the first power is x power 5, if the next is 3, the next is going to be 1 after this. And then the next one is going to be minus 1, and then minus 3, and then minus 5. So they always follow a pattern like this. So when you look at the first 2 terms are going to give you that pattern that you need. And then you can just figure out which specific term you need from the expansion. So in this case, you need x raised to power 1. Since the first power is 5, the next is 3. The next one is going to be x power 1, and that's all that you need. You don't need any other terms after that. So you just need to have one more term after this, after the first 2 in this case. What is the next term going to be? That's 5c2 into 3x whole raised to power 3 into minus 2 over x whole raised to power 2. And that's it. This is the term that you're looking for. You don't really have to expand the rest of it. You don't have to simplify the rest of it even. You don't have to simplify this. You don't have to simplify this. You know that this is the term that has x power 1, and that is what you need. You can just ignore everything else. Just expand or simplify this thing now. And that is going to give you the result. Now, what's 5C2? Just put this on a calculator. This is 10, 3x whole cube. That's 27x cube. Minus 2 over x whole squared. That's going to give us 4 over x squared. Now, 10 into 27 into 4. That is going to give us 1080 x cube and x squared in the denominator. That's going to give you 1080 times x. And that is the term that we were looking for. All right. Now, since the question says find the coefficient of x in this expansion, we would say the coefficient of x, therefore, is 1080. And we can just write it like this. The coefficient of x is 1080. So it's just as simple as this. Just do the normal expansion. The powers are always going to follow a pattern. And looking at that pattern, you can see what's the specific term that you need from that expansion. Then you can just simplify that particular term and just ignore everything else. It's a 4-mark question. It just requires this much. All right. All right, let's try another one now. Let's try another one from the worksheet, which requires you to do something similar. Now, this is relatively more complicated. This is question number 32 from the worksheet. Let's have a look at this. Okay, question number 32 from the worksheet. Now, what does this say? It says, find the term independent of x. Now, first of all, we need to understand what this thing means. Find the term independent of x. Independent of x means the term that does not have an x in it. That means a constant term, right? Or in other words, you could also say it's the term that has x power 0. So whenever it says independent of x, what you're looking for is the term that has x power 0. Okay, that's what we want. Now, how do we deal with this? Again, very similar to what we did in the last question. Let me first just copy this formula because we are going to need this there as well. This is the formula that we're looking for. Now, what do we do here? Let me write that expression down here. This is 4x cubed plus 1 over 2x whole raised to the power 8. What's the first term? The first term is 4x cubed. So the value of a, therefore, is 4x cubed. The second term is 1 over 2x. That's the value of b. And in place of n, the power, we've got 8. Again, how do we start? We just expand it like we normally do. Let's look at what the first term turns out to be. A raised to power n, that's 4x cubed whole raised to power 8 plus nc1, that's 8c1 into a raised to power n minus 1, that's 4x cubed. That's the value of a. Whole raised to power 8 minus 1, which is 7, into b, the value of b is 1 over 2x. And you're going to stop at this point and try to think about the pattern that emerges from this. Let's think about the pattern. So what's the power of x in the first term? X cubed, and then you have 8 here, 3 times 8, that gives you 24. So the first term has x power 24. That is your first term. What about the second term now? It's 3 times 7, that's 21. But you have an x in the denominator as well. So it's 21 minus 1, which is x power 20. That is the second term. And just by looking at these two terms, you can figure out what the pattern is going to be. The first term is 24. The next is 20. The difference of powers remains constant. So the next term after this has to be x power 16. And then the next one has to be x power 12. And so on. So the next is x power 16. Next, x power 12. The one after that is going to be x power 8. Then x power 4. And then we are going to have x power 0. And this is the term that you're actually looking for. This is the term that you're looking for. Now, how do you get to that particular term now? See what the pattern is. In the first term, you've got a power 8. In the next term, you've got power 7. Look at how these numbers are changing. So the top number with C, that remains constant. But you've got 1 here. And this is also the power of B here. This is also 1. So this is one number that's changing. And the other number that's changing is this. So it was 8 initially. In the second term, it became 7. Now, what is going to be these numbers? What are going to be these numbers in the first and the next term? After 7, the next term is going to be 6. And this number that was 1 initially, this is going to become 2. And the next term, it's going to be 5 and 3. And the next term, it's going to be 4 and 4. Then 3 and 5. And then finally, we're going to have 2 and 6 here. So in this term, this number 1 would have reached 6. So we can say this is 8 C6. What about the power of A, power of 4x cubed? It was going like this, 8, 7, and then 6, 5, 4, 3. At this term, it's going to be 2. And then the power of B, 1 over 2x. It was 1 here. It should be 2 then 3, 4, 5. And this is going to be 6 here. So this number reaches 6. And the number in green there, that reaches 2. Now, we can just simplify this term, and that's all that we need. So if you look at the pattern that emerges there, you can just figure out this specific term that's required from the formula itself. Let's simplify everything here. 8C6, let me evaluate this and see what this is. 8C6. All right, so 8C6 turns out to be 28. Then 4x cubed whole raised to the power 2. That's going to be 16x raised to the power 6. 1 over 2x. So that's 1 over 2. 2 raised to the power 6 is 64 into x raised to the power 6. X raised to the power 6 and x raised to the power 6 are going to get cancelled. And we're going to be left with 7 here. This is the term that we were looking for. We're looking for 7 here. All right. So all that we've got to do here is just expand the first two terms, and from that, figure out a pattern and see where is going to be the term that you need. And this is one example where this is probably one of the most complicated ones using this method, because the term that you need is coming at the end, towards the end. In most of the questions that you'll find, that the required term is actually going to be the third or the fourth or the fifth term at max. So you'll be able to figure that out using this method pretty quickly. Okay, so it's going to work much quicker than the other method that we will discuss. We'll do that as well in some time, in a few minutes. But I hope this makes sense. All right. Now, this method is also useful because you'll find in a lot of questions, you will need two terms. And when you're doing an expansion like this, you'll get both of those terms in the expansion itself. For example, if they required the term in x raised to power 4 and also in x raised to power 0, that happens in some cases. You could actually get them from this single expansion. You won't have to work for that another time. You can just get both of those terms from the same expansion. So it's pretty quick from that perspective as well, especially when you're asked about multiple terms in the same part. All right. Now let's discuss another method as well that you can use to find specific terms in an expansion. Let's do the same question number 32, and use another method for this. Now let's try to understand where this other method comes from first of all. Remember, I wrote this formula in our last class that this is what the binomial expansion formula looks like originally. Let me write this down here. Okay, so this is what the formula looks like originally. A plus b whole raised to power n. That equals nc0 into a raised to power n minus 0 into b raised to power 0 and so on. This is how this formula goes. Now, if you were to look at this, you will find that there's a pattern that is there in all of these terms. So for instance, if you look at the first term, what's the first term? This number is 0 here. This number is 0 here. This is also 0 here. So in the next term, you would see that only this number is changing. Everything else remains exactly the same. So in place of 0 in the next term, we've got 1. So we've got 1 here, and also as the power of b, we've got 1. In the next term, this number becomes 2. In the next term, this number becomes 3. And so on until this number reaches n. So in all of these terms, there's only one thing that is different. If we knew that for a particular term, the value of this number is, let's say, 3, we know that this is the term that we are looking for. So if we were to write a general form for every term in this expansion, it would look something like this, and it's called the general term formula. If you want to use this method, you'll have to remember this formula, and it looks like this. What is happening in every term here? This one number is changing. What we do is we call this number R, the number that is changing with every term. If you were to call this number R, the general term formula is going to look like this: N C R a raised to power n minus r into b raised to power r. This is what this general term formula looks like. You can find any term using this formula if you know the value of r. So the problem in this case would just be finding the value of this r. Once you have the value of r, you can just input that there and you can find whatever is needed. Now let's see how this is going to be used. We've got this expansion, 4x cubed plus 1 over 2x whole raised to power 8. We want to use this formula, this general term formula, to find the term that is independent of x. Remember, independent of x means we're looking for the term in which the power of x is 0. Okay. Now, what do you have in place of a in this expansion? So remember, your general form is a plus b whole raised to power n. If you were to compare with that, in place of a, you've got 4x cubed. In place of b, you have 1 over 2x. Now, just input values in this formula, and this general term formula, and see what that gives you. So what's the formula? It means write that here again. NCR into a raised to power n minus r, b raised to power r. Let's input values in this. Do we know what n is? Let me just write that here again. N is 8. That is also known. The value of n is 8. Let's input values in this formula. So we'll get 8 CR. R is unknown. We need to find that. But we know A and B as well. What's A? A is 4x cubed. 4x cubed raised to power n minus r. That's 8 minus r into B. B is 1 over 2x whole raised to power. Then you have whole raised to power r here. This is what every term in the expansion of this thing is going to look like. Every term is going to follow this pattern. All we need to figure out is what the value of r is in the term that we are looking for. Now remember, which term are we looking for? We are looking for the term that has x power 0. That's the term that we are looking for. The power should have 0. So what we do for that is, we say, let's simplify the x terms in this formula. Only the x powers of x. You can just ignore everything else. Just focus on x for now. You got x cubed here. Let's write that here. X cubed whole raised to power 8 minus r. So that is also being multiplied with the power 3 here. 8 minus r. Where else do you have x here? You've got x here in the denominator. So again, ignore all the other numbers. Just focus on x for now. In the denominator, you've got x, and the whole power is r here. Now, if I were to simplify this, 3 times 8, that's 24, minus 3 times r, that's 3r. In the denominator, I've got r. Now, if I simplify this further, it becomes x raised to power 24, minus 3r, minus r, which is 24 minus 4r. What do I want this thing to be? This needs to be the same as x raised to power 0. So this power of x, this has to be equal to 0. What we can do is, we can find the value of r from this, because since the power has to be 0, that means 24 minus 4r, this has to equal 0. And that gives us the value of r equal to 6. Once we know what the value of r is, all we need to do is input that value of r in this general term formula, and that's going to give you the required term. So 8c6, in place of r, you input 6, and you have 4x cubed whole raised to power 8 minus 6, which is just 2, into 1 over 2x whole raised to power r. The value of r is 6. Let's simplify everything. 8c6 we found earlier, this was 28, and you have 4x cubed whole raised to power 2, which is 16x raised to power 6. In the denominator, you got 64x raised to power 6. Simplify all of this, and that is going to give you 7. So this is another possibility, that you use the general term formula. You'll have to remember this. You have to memorize this formula for that. This thing, NCR, a raised to power n minus r, b raised to power r. And if you memorize this formula, just input values of a, b, and n in this, like this. Then simplify only the powers of x. That's what you've done here. And put the power of x equal to whatever is required by the question. So in this question, they were asking for the term that was independent of x. That means x power 0. So what we do is, we put the power of x equal to 0. So 24 minus 4r equals 0. That gives us the value of r. We input this back in this general term formula, and we get the required term. All right. So that's how you deal with problems like these, where you have to find a specific term. Let's do another example. Let's do another example from the worksheet. Let me find that. Okay, let's look at this last problem, for instance. Question number 34. Let's use both methods for this, just to get a bit more practice. Question number 34. And I'm going to use both the methods for this, and then you can choose for yourself whichever you're more comfortable with. I generally find this to be much quicker, that you just expand this thing and find that coefficient. There's a pattern that always emerges, and you can find that required term pretty quickly using that pattern. So you won't have to memorize that general term formula as well in that case, because this formula is already given in the formula sheet. You can just use that. Now, let's try doing this using both methods. Okay, so first of all, we've got this expression x squared minus 2 over x whole raised to the power of 5. We're looking for the coefficient of x in this expansion. How do we start? We could just start by expanding it like we normally do. X squared minus 2 over x whole raised to the power of 5. What do you have in place of a? In place of a, you've got x squared. In place of b, you've got minus 2 over x. Do not forget the negative sign. That's also a part of b. And the power is 5. Let's input values in this. A raised to power n, that's x squared whole raised to power 5. Plus 5 plus nc1, that means it's 5c1. A raised to power n minus 1, that's x squared whole raised to power 5 minus 1, which is 4, into b, which is minus 2 over x. And now you can just stop at this point and try to think about the pattern that you're getting. What's the first term? The first term is x power 10, right? X squared whole raised to power 5. 2 times 5 is 10. What about the second one? You've got x power 8 here. In the denominator, you've got x. So that's x power 8 minus 1, which is 7. All right. And that gives you the pattern. The first term is x power 10. The next is x power 7. What should be the next one after this? It should be x power 4, right? There's the difference of minus 3. So 10 and then 7 and then 4. And the next term after that is going to be x power 1. And you see, that's the term that we're looking for. Now, what do? You've got 5c1 here. Next is going to be 5c2. And the next after that is going to be 5c3. And that is what we need. We need the term that has 5c3. We're not looking for the x power 4 one. We can just ignore that. We can just ignore that. X squared whole raised to power 4. The next term would have had 3 as the power. So the next after that has 2, right? This is 4. The next would have been 3. The next after that is 2. The power of b, it's 1 right now. The next would have been 2. So this one should be 3. And that's the term that you're looking for. Okay, that's pretty quick. Now, what's 5c3? 5c3 is 10. You just need to simplify this. Ignore everything else now. Just simplify this term because that is what you want, the coefficient of x. Simplify this. 5c3 gives you 10 into x raised to power 4 into minus 2 over x. Minus 2 raised to power 3 is minus 8. In the denominator, you've got x cubed. Minus 8 into 10, that gives us minus 80. X power 4 minus 3, that's x. This is the term that we were looking for. They were asking for the coefficient of x. We could say the coefficient of x is minus 80. And that's what we were looking for. The coefficient of x is minus 80. All right. So this is using the first method. Now let's use the other method on the same example as well. And let's see how that works. We've got x squared minus 2 over x. whole raised to power 5. This is what we want to expand. Remember what the general term formula is? That looks like this. NCR a raised to power n minus r into b raised to power r. Now compare it with the standard form, a plus b whole raised to power n. What do you have in place of a? In place of a, you've got x squared. In place of b, you have minus 2 over x. And in place of n, you have 5. Let's just input values in this standard form. NCR, that's 5 CR into a raised to power n minus r. A is x squared raised to power n minus r. N is 5. That minus r. Into b raised to power r. B is minus 2 over x and then whole raised to power r. Now, what are we looking for? We are looking for the term in x power 1. That is what you're looking for, x power 1. So what you do is, you just simplify the powers of x in this case. What do you have in the numerator? In the numerator, you've got x power 2 into 5 minus r. Or let me just write it down like that. First, x power 2, x squared, whole raised to power 5 minus r. That's what you have in the numerator. In the denominator, you've got x power r. That's coming from this. Okay, we're ignoring everything else. We don't need anything else for now. We're just looking for the value of r first of all. Simplify this. This gives us x raised to power 10 minus 2r in the numerator. And then this r from the denominator, you have another minus r. And this gives you x raised to power 10 minus 3r. What were we looking for? We were looking for x power 1. Just compare the two. The power should equal 1 because that's the term that we're looking for. We put this equal to 1. 10 minus 3r equals 1. And that gives us 3r equals 9. And the value of r turns out to be 3. Once we know the value of r is 3, we put this back here. And we get 5c3 into x squared whole raised to power 5 minus 3 into minus 2 over x whole raised to power 3. Let's simplify this. 5c3 is 10 into x squared, which is x power 4. And then you have minus 8 over x cubed. And that also gives you minus 80x. So you can say the coefficient of x is minus 80. So this is this is the coefficient of x using the other method now. All right, so you can use both of these methods, any one of them that you prefer. As I said, if you were to use this one, you'll have to remember this formula. You have to memorize this formula, the general term formula, and then you can use it, and that's perfectly okay. But I find the first one much quicker in that you just have to expand it like using the normal formula. Simplify, look at the pattern, figure out where you're going to get the term that you need, and then just simplify that particular term and you get the result directly without having to memorize the formula. And it's much simpler as well. There's less complication. All right, let's do one last question before we end. Let's do one more question. Let's take a slightly more complicated one. This is question number 33 from the worksheet. Let's try this. Okay, this is question number 33 from the worksheet. Let me copy the formula here as well. Now I'm going to be using this first method. This is much easier. just expanding it like you normally do. So let's do that. Okay, this is the formula that we've got. Now let's think about it. Okay, I'm sorry, this is not the exact formula. Let me go back there. Let's use this one. All right, now let's think about this. We want to find the coefficient of x squared in the expansion of this multiplied by this. Now remember, we discussed whenever you have a product like this, in which one of them has a power on it and the other does not, you first need to think about which specific terms you need from the expansion of this thing. All right. Now, since you've got 1 plus x squared here, you need to start by thinking about this first. Don't just jump into it directly and start expanding this whole thing. You might not need to expand the whole thing. You just need some specific terms. Let's think about that. What do we want at the end? We are looking for the coefficient of x squared. Now, this thing is already simplified. There's no power on it. So we will just be multiplying one with a term in the other expression and x squared with something in the other expression as well. Now, what multiplied by 1 in the other expression is going to result in the x squared term. A constant multiplied by x squared term is going to result in x squared. So we'll have to multiply 1 by x squared to get the coefficient of x squared. Okay. But that's not the only term that we need. We also have x squared here. X squared will also be multiplied with all these terms in the other expansion. Now, what multiplied by x squared can give us x squared as the result? A constant. Or we could say x power 0. So from the second expansion, we actually need to figure out two terms, x squared and x raised to power 0. These are the two terms that we need from this expansion. All right, because 1 multiplied by x squared could give us x squared. That's what we need. And x squared multiplied by a constant could also give us x squared at the end. So we're looking for both of these terms from this other expansion. We're looking for x power 0 and also x power 2. We want both of them. So how do we think about this now? We start by expanding this thing. X over 2 minus 4 over x whole raised to power 6. Let's consider that separately first. We want the x squared term from this expansion and also the x power 0 term from this expansion. These are the two terms that we're looking for from this expansion. X power 0 and x power 2. Now, how is this going to work? In place of a in this expansion, we've got x over 2. And in place of b, we've got minus 4 over x. All right. In place of a, we've got x over 2. And in place of b, we have minus 4 over x. And in place of n, we have 6. Let's just input values in the formula. A power n. That's x over 2 whole raised to power 6. Right? Plus nc1, which is 6c1 into x over 2 whole raised to power 5 into b, which is minus 4 over x. We stop at this point and think about the pattern that is emerging. The first term is x power 6. What about the second term? You've got 5 in the numerator, 1 power in the denominator. So the second term is going to be x power 4. And now we have the pattern. If the first is 6, the next is 4. The one after this is going to be x power 2. And that's one of the terms that we're looking for. And the one after this is going to be x power 0. And we also want that term. So we have found those two terms pretty easily from here. the x squared term is going to be 6c2, the one after this, which is x over 2 whole raised to power 4 into minus 4 over x whole squared. This is one term that we're looking for. And then the x power 0 term, that's going to be the next one after this, using the pattern. That's 6c3 into x over 2 whole raised to power 3 into minus 4 over x whole raised to power 3. And this is all that we need. These are the only two terms that we need. We could just ignore everything else. You don't even have to expand any further and not even simplify the first two terms. Just simplify these two terms and that's it. What does this give us? 6c2. 6c2 is 15 into x over 2 whole raised to power 4. That's x raised to power 4 over 16 into minus 4 over x whole raised to power 2. That is 16 over x squared. The second term is 6c3, which is 20 into x cubed over 8 into minus 64 over x cubed. All right, let's just simplify this now. So the first of the two terms that we need gives us this, and the second term here is giving us this. Now let's just simplify both of them. The first is going to give us 15 x raised to power 2. That's one thing that we need. And the second one is going to give us 20 times 8, which is 160. And x cubed and x cubed are going to get cancelled. This is what we have from this expansion. We're ignoring everything else because remember, what were the two terms that we were looking for? We were just looking for the constant term and the x squared term. We've got both of them. All right. Now, let's just input these values in that original expansion that we had to do. What was that? 1 plus x squared into this expansion. Now, what did we need from that expansion? We just needed the x squared term and the constant term. We found that there. 15x squared minus 160. What are we looking for? We're looking for the coefficient of x squared. How can we get that? We can just multiply 1 with 15x squared and x squared with minus 160. And that is going to give us the required term. That's 1 into 15x squared plus x squared into minus 160. And that gives us 15x squared minus 160 x squared. And that's minus 145 x squared. Since we were looking for the coefficient of x squared, that turns out to be minus 145, and that is our answer. Okay, now notice here we were actually looking for two terms from the expansion, x squared and x raised to power 0. So if you were to use that general term formula, you would have had to find two values of r and then find these two one by one, 15x squared and minus 160. You'll have to apply the general term formula twice. Here, it's much simpler. You just do one expansion and you get both of those terms directly from that one expansion. All right. I hope that makes sense and is helpful. We will see if we need to spend a bit more time on this tomorrow and doing some more practice questions, but that's it as far as the concepts are concerned. We're done with all the required concepts. In the next class, we'll see if we can do some more practice. And after that, we're going to move on to our next topic, which is arithmetic and geometric progressions. All right. Thank you, everyone. I'll see you again tomorrow. Allah Hafiz.